So the electrolysis of concentrated sodium chloride between inert electrodes is used to make four important chemical cells. Okay? Hydrogen chloride, sodium hydroxide chloride. Okay. The ion present, hydrogen ions are discharged at a negative electrode. Write an equation. So lah, if you don't know how to write this, I've already taught you. We're all going to sit down and cry. Okay? Did you get it correct?
Of course.
Okay? Right? We've done
Yeah.
it many times. Okay? So negative electron is always gain electron. Gain electron is called oxidation and reduction.
Oh,
Reduction. Okay? Gain electron is always called reduction. Okay, the hydrogen ions are from the water. So just an explanation why concentration of hydroxide ions increases. Okay, see, this is equilibrium. As the hydrogen ions are used up, the equilibrium shifts to the right or to the left? To the right.
Um,
To replace the hydroxide, the hydrogen ions are used up, so hydroxide ions also increase. Okay, so the equilibrium to the right. To replace hydrogen ions removed. Okay?
Here. My school just started equilibrium.
Equilibrium.
Yeah.
Equilibrium, yeah. When when a dilute solution of sodium chloride is used, chlorine is not formed. A different gas. So if it's concentrated, remember, concentrated, you choose chloride. But if it's diluted, you choose hydroxide. Hydroxide becomes what gas? Oxygen. You still got it wrong, Jung.
No. I put in hydroxide instead of oxygen.
The gas, write this equation down. The gas that is formed. Okay. Inert electrode is graphite.
So actually, can I write hydroxide instead of oxygen?
Hmm?
Can I write hydroxide instead of oxygen?
Hydroxide instead of oxygen, no can.
Um, so everything I need to change to oxygen form.
Because the question asks you gas. Highlight the word gas. Okay. Ready? All right. State one use of hydrogen as a fuel. Why is chlorine used to kill bacteria? Okay. Hydrogen fuel cell is like this. Okay, can you write this down? Hydrogen fuel cell. Okay. So here you put hydrogen, here you put oxygen. You force it to react and electricity is produced. So it produces electricity. Okay, and the equation is like this. But there is no greenhouse gas produced. So it's a good thing. Okay, so hydrogen is used as a fuel. But why don't we use more of this? It's difficult to Okay, ready? Can? All right. The results of experiment on electrolysis of inert electrodes are given. Okay, if you make potassium, that means it has to be molten. It has to be molten because if it's not molten, you won't get potassium. Molten potassium what? Iodide. Oh, what is that? Wow, oh, you all today are very lucky.
뭔 줄 알아? 김밥이야.
What is that?
감사. 김밥.
Oh, thank you, thank you. Wow. So lucky you today.
Good. Like Korean juice.
Oh, like crazy. Oh,
I think actually to open the steam.
oh.
Can eat?
Eat lah, you all hungry then eat lah. Oh, oh. I will never offended if you eat. I will also eat. Okay? All right, I will write. You all can eat. Dilute aqueous sodium. So dilute sodium chloride. You always have to write the ion. Okay, we have done electrolysis 3,000 million times already. So who is chosen? Joe, sodium or hydrogen?
So hydrogen.
Hydrogen! Group 1, Group 2, Group 3 never chosen. So you choose hydrogen. Don't give him to eat. Dilute means you choose hydroxide. So oxygen form. What is left over if I remove hydrogen and oxygen? It becomes more diluted or more concentrated? Concentrated. So I'm left with concentrated. Oh my god, so good. Oh. Our mind. Okay. Your role is copper transition metal. So you choose copper. The only choices are chloride, bromide, iodide. Sulfate is never, ever, 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 ever chosen. So you get oxygen.
Teacher, I think I need to bring back my memory.
Yeah, you left it in Shanghai. Shanghai too much fun. What's left over? Sulfuric acid.
Can I write aqueous instead of
You
concentrate?
have you have to write concentrated aqueous. Concentrated and aqueous. You write both. Okay?
Next class also can do electron.
Hail will physically kill you. You go home and study again.
Okay.
Study again, okay? Copper has a structure of a tapered metal. Okay, this is metal Remember positive metal ions. Okay. Positive metal ions in a sea of free electrons. Okay? So it can accommodate different metals. What is that called, Hayun? Swallow first, swallow first.
Um,
Alloy.
yeah.
Okay. Ability of ions to move past each other is called
Oh,
malleable.
malleable.
Presence of mobile electrons is can conduct electricity.
Is it malleable like oh wait, that's the
Ductile also can. Ductile also can.
That Malay's mouse.
make
Oh, make and so
No, conduct electricity for electrical wire. Must finish the sentence, sorry. So it's malleable or ductile to make you can say make bridges, to make other things, to make car body and okay, good. You did? Good. Aqueous copper to sulfate solution can be electrolyzed using carbon electrodes. The ions present in the solution are follows. Write the ionic equation for the negative electron. When they talk about this, it means a half equation. Okay, negative electron. Who do I choose? Copper or hydrogen? Copper or hydrogen? Transition metal. Copper. This is recorded, so you can listen to me
no.
scolding. Okay. Who is the colorless gas? Sulfate or hydroxide chosen? Hydroxide ions discharge to form what gas?
Oxygen.
Mm. The solution changes from blue to colorless. What is left over? Sulfuric acid remains and is colorless. Mm. Okay. Is this the last question? Last page, yeah? Last page, right? Yeah. Aqueous copper 2 sulfide can be electrolyzed using copper electrodes. The reaction and negative pressure is the same, but first electrode becomes smaller. Why? This one copper becomes copper ion, right? This one is like this. This one made from copper, this one made from copper. Solution also got copper ion. Here, copper ion become copper metal. Here, copper metal become copper ion. Remember that?
No.
Hmm? Okay. Large scale use means what do you use this electrolysis for? This is used, okay, this one you don't learn anymore. It's to purify copper. Is that all? Okay. All right. Take out your textbook.
Which one was the
Second one. Turn to page 38, this part.
any of the chapters?
Yeah, because she was asking for this. But we'll go back to it. Okay. Now, do you have this book? Okay. Properties of metals. What we talked about just now. Metals can conduct electricity, can got heat, it's malleable and ductile. They have high melting points and high boiling points. Metals can react with acid, metals can react with water or steam, metals can react with oxygen. Okay, so describe the uses of metals. Okay, so uses of metals means like what? Okay, so what are metals that we learn in this chapter? So we learn this reactivity series that you kind of need to memorize. Potassium, sodium, calcium, magnesium, aluminium, zinc. Wait, don't copy first, ah.
Maybe also learn sodium.
Any?
And like lithium.
No, lithium, no. Lithium no need to. It's in group, periodic table group one, but not really. But it doesn't make a difference. It's just potassium, sodium, chloride, lithium.
Oh, there was something.
Wait, ah, wait, ah. Okay, now potassium, sodium, calcium, magnesium, aluminium, zinc, iron, copper, silver, gold. But we also learn some non-metals, which are carbon, not carbon dioxide, and hydrogen. Okay, can? So the higher it is, the more reactive. So, for example, potassium, sodium, calcium react with water, whoosh, kaboom, explode. Magnesium react with water very slow, but magnesium can react with steam. Get it? Then everybody else doesn't react. It's very simple. Okay, dilute acid, everybody can react until here. Copper, silver, gold don't react with acid because they're below hydrogen. Everybody can react with oxygen, but the reaction gets slower or faster as you go down. Slower. That's it. Loh. Very easy one. Okay? So, aluminium is special. Although aluminium is more reactive, aluminium is special because aluminium is very low density. So it's used to make aircraft. Okay? It's also used to make overhead cables because it's very low density. And it's used to make food container because it's very resistant to corrosion. We'll learn more about this later. Okay? Copper is used to make electrical wiring. We just learned that just now. Okay. All right. What is alloy? So here is a pure metal. Okay. All the metals are same size or different size?
Same size.
Same size. So if I knock them or push them, they can slide over each other. So because they can slide over each other, they are malleable. They are ductile. So if I do alloy, alloy is a mixture of a metal and another element. It doesn't have to be metal. It can be anything else. But because it's a different shape, it changes. It's no longer in layers. So now it's harder and cannot slide. So that's why we use it to make alloy. Okay, who do you need to memorize? Copper and zinc make brass. Iron and carbon make steel. Iron and carbon and chromium and nickel make stainless steel. Okay.
What's the difference between stainless steel and
Steel is the one you use to make house, bridge, car. Stainless steel is the one used to make surgical knife, the expensive one that does not rust at all. Okay. Okay. Ready? Okay. Reactivity series. Now, I want you to try and write potassium with water produces potassium hydroxide and hydrogen gas. Okay, it's very, very reactive. Okay, I want you to try and write the reaction of sodium and water and calcium and water. Can you try and write here? Okay. Remember the list or not? Potassium, sodium, calcium,
carbon
magnesium,
and carbon?
then zinc, then iron,
Hydrogen.
hydrogen,
Hydrogen.
copper,
Copper.
silver,
Gold.
gold. Okay, write down the equation. This one is the equation of potassium and water. Try and write sodium and water and calcium and water. Okay?
Two plus, right?
Don't know. Think. Will it? I'm not saying no. I'm saying maybe.
Mm.
Okay. Eat ready, so I have a lot of energy to do your homework. Remember, I give you a clue, okay? Why? How to memorize? Actually, you can look at your periodic table. Look at this, this and this here, group one, group two, group three. And then transition metal, which are not chosen for which are chosen for electrolysis. Okay? Okay. Ready? Do you remember how to do it? Just do the same thing. Same thing. Sodium is also in group one. So Na is plus, OH is negative. So you get NaOH. And you also get hydrogen. Okay? Did you get this correct? Calcium. 2 plus or 1 plus? 2 plus. So it's CaOH bracket 2. Okay? So you go 2, 2, 2. Okay? Okay? Is it balanced? No, like not balanced like that. Wait. 2, 2. Now it's balanced. Okay. Now it's balanced. Can I understand? So magnesium is very, very slow because magnesium is lower, ma. Right or not? So magnesium doesn't react with water. Magnesium reacts with steam. What's the difference between steam and water? Steam is really, really hot, so it doesn't dissolve. So magnesium just reacts with the steam. And then, so the difference is this one is this tree, this one is liquid, 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 but this one is gas. So this one is aqueous, 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 but this one is solid. Can you understand? Can see it? Ready?
Is it like similar with the acid bases and salt?
Yes. All right. Now, finally, who do you think can react with acid? Magnesium, zinc, iron, copper, silver, gold. Everybody? Yes, no?
No.
No, only? Magnesium, zinc, iron. Copper, silver, gold don't react with dilute hydrochloric acid. Okay? So, can you please write down equation? Acid and metal. We did this that day. Acid and zinc, acid and iron. Okay, do it now. Okay, ready? Done or not? Okay. So acid and metal. Are you done? Salt is magnesium, MgCl2, and hydrogen. Balance equation. This one is ZnCl2 and hydrogen. And this one is FeCl2 and hydrogen. Okay, it just follows the same trend. Okay. Right, ready? Now, this last part. Explain the, oh my gosh. Explain the apparent, explain the apparent unreactivity of aluminium. Aluminium is supposed to be here. Aluminium is unreactive. It doesn't react with acid so fast. Why? Aluminium is special.
Low
Okay. No, not because of that. See, this is aluminium. Aluminium forms a layer of oxide on the surface. But other people's oxide is very crumbly and weak. Aluminium oxide is very strong. So the layer of oxide is like a raincoat like that, like a plastic cover.
Mm.
So water and oxygen cannot go in. So the inside is saved from corrosion.
How if we cut
It will form another layer.
wow.
Yeah. So immediately after it's exposed, it forms a layer and that layer stops the inside layer forming. So it's all the same actually.
So it's like independent.
Yes, yes. Every time you cut it open, it will form a very thin layer. Get it?
Any difference? Like the outer layer is shiny, inside is not shiny.
You can't really see. You can't see like aluminium foil, you open the aluminium foil, the one that is shiny and not shiny, actually both also got a layer of aluminium oxide. It just eventually it will form a layer. That's why it doesn't rust. It's already rust. But you cannot call it rust. You call it aluminium oxide. You call it layer of oxide. Get it? Okay. Now, here, conditions required for rusting. This one you learn when you were in year 7. How does iron rust? Iron rust when there is water and oxygen. Okay, now we're going to learn why. This is iron. You don't need a lot of water. You just need 1 drop. Water alone can iron rust? No. Why not?
Because there's no oxygen.
Why? Water alone is, okay, you know how your school, right? Sure got this person A by themselves is not naughty. Person B by themselves is not naughty. But when person A and person B are together, they're very, very naughty. Got or not? Yeah. Aluminium alone, not naughty. Oxygen alone also not naughty. But when oxygen and water get together, they become gangster. They start to steal electron. They are big time gangsters that want electrons. Where do they get the electron from? From iron. They force iron to release electron. The moment iron starts releasing this electron, iron has started to rust. Rusting started. Okay? From Fe become Fe2 plus. Remember, rusting is not becoming brown color yet. Rusting is just release electron. It's just iron release electron.
Yes, you know,
Hmm?
there was this bracelet, it was metal,
Uh-huh.
and it rusted. But I don't know, I didn't even use it.
It's in the air, there's water, what? Water
Oh,
vapor, what?
oh,
Hmm.
But isn't it water got oxygen and oxygen got water?
No, separate, separate. It has to be separate because water is a compound, oxygen is a molecule. They have to get together to form hydroxide. Don't you see this equation is the opposite from the electrolysis equation?
yeah.
Yeah. So it's like a gangster. I want electron. When they take electron, then you are causing somebody to corrode. Get it?
So corrode is rusting.
Corrosion is rusting, yes. But rusting can be only used for iron. Okay? All right. So how can you stop this from happening? You make sure there is no water and oxygen. So paint. You use paint, grease, plastic. Okay. So it stops the oxygen and water. And then one more thing we're going to learn is zinc. If you take the iron and you completely coat in zinc, this is called galvanizing. Does galvanizing stop? Huh? Yes. Huh?
Remember,
Okay.
and to like slow down or something.
No, it stops, completely stops. It's a barrier, it completely stops. But here's the thing. Okay, wait, let you all finish writing.
But what to do?
Yeah, not now lah, later wait.
Is it anymore?
No, do now lah.
Okay.
Then the rest go home and do.
Um,
Is it man?
No, it's not lah. Where's the stapler? Yes. Claire, can pass me the stapler? I think so, no. The other one? The person? So, no, so, no, yeah. Okay. Is zinc more reactive or less reactive than iron?
No.
Zinc is more reactive, less reactive? More reactive. So, who wants to release electron more? Zinc or iron?
You see?
Zinc. So, what happens is, if, okay, this is the iron, if the iron is completely covered with zinc, okay, oxygen and water cannot go in. Right now. Okay, so no problem. Okay, no problem at all. So this is called a barrier method. It's a barrier to stop oxygen and water going in. Right?
Yeah.
Okay, now what happens if the zinc is scratched?
like completely water.
Okay, so if the zinc is scratched, like that, so scratch, open now is open exposed. Or I have a ship in the water that is made from iron, and here I put a piece of zinc. Okay, same concept, ah. Now, who is more reactive, zinc or iron? Zinc. So when the water and the oxygen come and tell them, gangster ma, I want my electrons. I want my electrons. Iron is like, don't want to give. Zinc say, I give, I give, I give, I give. So what does iron have? Okay. So zinc corrodes. Zinc is the one that corrodes. What does iron do? Nothing. So zinc is more reactive. Zinc release electron. If zinc release electron, does iron release electron? No. So who is the one that corrodes? Zinc. So this is called I sacrifice myself for you. So it's known as sacrificial protection. This is sacrificial protection. Okay? Okay, I give you a few seconds to absorb all this knowledge. I'm going to give you questions on this, okay? This one, no, this part no need to do, okay? Let's start from here. X is with cold water. So X definitely is either sodium or potassium lah. What else can it be? Hydrogen gas, you use a burning, burning. Splint will do what? Will do what? Pop. Squeaky pop or pops. How can you show it has XOH? Litmus, red litmus paper turns blue because it's alkali.
Which I read it
What do
like
you mean?
How do you contain a compound type XOH? How do you know it's an alkali lah? They're trying to make it
Ask like what how to make it like seem as if it contains water, so I wrote like hydrate.
um,
oh my goodness.
electrolysis of molten or aqueous? Group one. I want to get group one metal, molten or aqueous. See how clever you are when someone shouts at you? Of molten X chloride. Okay.
Just now there was only two selection.
Huh?
Just now it was
Yeah, if I want to get hydrogen, if it's group one, two, three, and hydrogen, I choose hydrogen. If it's transition metal, I choose transition metal. Now I'm telling you, I want the group one. If I use aqueous, I will get hydrogen. So I must use something where got no hydrogen. So what is no hydrogen? Okay? Okay. I cannot teach that student like that, no. He will cry all day. Okay, everything also don't know, ma. I'll be shouting and shouting and shouting all day to him. CO2.
He has a soft part.
No, he's just she's not dumb. He's not dumb. He has no special needs, nothing. It's just laid back, trained until like that. This is the type of children, you know. Oh, you don't know how to do ah. Oh, you no need to do lah. I tie your shoelace for you. Like, if you really got learning disability, I understand. In fact, those are my kids who have learning disability. They are even more hardworking because they want to overcome. Huh?
What's learning?
No, learning like dyslexia. Not my kids. I got students dyslexia, dyscalculia. I got students who cannot hold their pencil properly because they have what you call it? The muscles are not coordinated. I got one student, okay, he cannot write. He has autism and he has muscle kind of like muscle dystrophy. So until he writes it's like that. So he has to write really, really slowly. Then only he can do. He managed to get A, for subjects.
I heard like people like some of them they can't read on paper.
Yeah, yeah.
So, like,
The dyslexia lah.
so that's take their advice just say something to it.
Yeah. So you can get a scribe. That means someone reads it to you and then they write it for you.
Oh, miss, when I old school, so you don't have that. And my sister's here,
Uh-huh.
and they were taking GCSE,
Uh-huh.
and they cheated, and they got caught, and they got disqualified.
Yeah. Okay. This one, going up is more reactive. More reactive means love to gain electron or love to throw electron. Give or take electron. Give. So zinc, iron, tin, and copper. They all, who loves to give electron the most? Zinc. But everybody can give. Everybody can give electrons. But zinc loves to give the most. Get it? You imagine them on stairs. The one on top will always give the electron to the one below. Okay? But the one below, in order to catch it, should they be an ion or should they be a metal? If they want to catch, if zinc wants to give copper, this equation happens for zinc. Okay? This equation happens for zinc, right? Copper, if copper wants to react, should it be copper metal that catch the electron, copper ion that catch the electron? Copper ion. Ion means I got no electron, I catch yours. So it would be zinc give, like that, zinc give the electron, right? Copper must catch it, right? So copper ion, you catch my electron, catch the electron, become copper. Can you see? Can you see what's going on now? So the one on top can throw, the one below can catch. Okay, now do this. If no reaction, right? No reaction. If there's a reaction, finish the reaction. So like this, copper and tin. Can copper throw and tin catch? Huh? No, no reaction. Iron and copper. Can iron throw and tin catch? Yes, remember only the metal can throw. So the metal throw become Fe2 plus. Like that. Okay, do the last one. See whether you can do that.
It's basically like ionic equation.
Yes.
Always the throwing one is the front one.
Yes, the metal. What is this one? This one is no?
Reaction.
No reaction. Okay, ready? Get it? Three products when tin nitrate. Okay, this one you don't learn anymore, but I write down the equations. You balance it. You balance this equation. Okay, ready? No. Okay. Okay. Can balance it ready? So it's 2, 2, 4. Okay, so what is produced?
Oxygen.
Tin 2 oxide, nitrogen dioxide, oxygen. Okay, ready? All right. Brass and alloy. Copper. I told you just now. Alloy, two reasons why an alloy such as brass is preferred to either of. Or that means why a mixture is better. It's more resistant to corrosion.
Can I say no corrosion?
No, more resistant. It's harder. Okay, and then it's enhanced beauty. That means more beautiful lah. You want to say it looks prettier also can. Okay. In an experiment to investigate rate of rusting in steel, three pieces of steel were used. One piece of steel was completely coated with copper, one piece of copper coated with zinc, the piece was uncoated. So when a coated piece started to rust, okay, iron exposed to water and oxygen in air. Okay. Okay.
Can I say just react with water and oxygen?
Can. Okay, so you see, this question is like this, this question, very interesting. Okay, this is iron is, steel is basically iron, we don't need to worry about that. So, the first one is coated with copper, but then it was scratched. The second one is coated with zinc, it's scratched. Which one the iron will rust? Copper, because iron is more reactive than copper. Get it? So then, ah, so you need to write iron is more reactive than copper. Iron will release electrons and corrode when with copper. Zinc is more reactive than iron. Zinc will release electrons instead of iron. This is sacrificial corrosion. Oh, sacrificial what? Protection. What was it? Wait, chok, Sacrificial
Protection.
protection. Yeah. Basically, when iron is with zinc, zinc says, take me, take me, take me. When iron is with copper, copper hide behind iron. Iron, okay lah, I rust. Everybody take this, go home and do. Last paper.
It's sincere or nuclear.
Yes.
And the completable
Can. Okay, do this question, this paper.
Simple.